Hello all, welcome back to a new episode in our how-to video series. In this episode, we're going to look at two connectors that you will find on an array board, the growth connectors. The growth connectors are general-purpose connectors with 4 pins, which are popularized by the Seed Studio. 2 of these pins are for power and ground, while the others are for data. When the growth system is connected to an I2C channel, the 2 pins would be used to carry the clock and data signals. If the port is EWARD, then the signal pins would carry the RX and TX signals. They can also be used as analog and digital pins. The 2 signal wires are marked yellow and white and are connected in a straight-through configuration. Growth on the array boards are typically placed on the far end in the expansion area. There are 2 growth connectors designated J27 and J28 and are called growth 1 and growth 2 respectively. The growth 1 is recommended to be used as channel 1 in I2C master mode, being connected to pins 511 and 512. And growth 2 is recommended to be used as channel 6 in I2C master mode, with the data and clock pins being 506 and 505. These pins can also be used as analog pins, so they can be used for ADC applications. For our demo, we shall be using a Renesas HS3001 temperature and humidity sensor that can be connected to the array MCU through I2C channel. For the cable, we are going to use a growth connector with broken out headers. The wire connections are shown here. The sensor board comes with a standard PMOD 12-pin connector. You can remember the connection referring to the colors and pin number. The yellow wire is used for clock signal and connected to pin 3, and the white wire is connected to pin 4 and carries the data. Here's how the cable will look like with being connected to the growth 1 socket. For the application demo, we are going to import an I2C project for this sensor. Once the project is imported, we will check the I2C stack. By scrolling in the properties section, we can see that the assigned pins for this communication are the 511 and 512, which are exactly the MCU pins hardwired to the growth 1 connector. The sample program code is found in the hull entry file, and it will produce the temperature and humidity values obtained from the sensor. We shall build a program and debug to start running on the MCU. When the program has uploaded to the MCU, we can then press this resume button twice to start the application. When the program is running, we can view the values of temperature by inserting the appropriate variables in the expressions tab. This can be found on top right during the debug perspective. When we enable the real-time refresh, we can see that the values are updating, which confirms our I2C connection through the growth 1 port and proper functioning of the sensor. This can be repeated with the growth 2 socket as well, and the application needs to be configured with the channel 6 in I2C mode from the SCI port. Well, so that was a small introduction to the growth connectors which can be used as I2C ports. See you in the next video.